Hi everyone. This is the 30, 60, 90 reference triangle. So we covered 45, 45, 90. This is now 30, 60, 90. Okay, so there's only two types of reference triangles. And obviously they're always right triangles, so they have that 90 degree. Okay. All right. The notes are examples because the 45, 45, 90, so that's example one. Okay. And then after I'll pan over the other sheet, which has example 2, 3, and 4. Okay, same thing. I will solve them two ways. The color method, which is a statement of proportionality, and then the shortcut, which you're essentially solving by mental math. You're finding the scale factor and you know what steps to take. Okay, so we'll see how long this video is. Hopefully like around 20 minutes because I'm just gonna dive right into it. Okay, so unlike the 45, which has legs 1, 1, rad 2, the 30, 60, 90 has legs 1, rad 3, and the hypotenuse is 2. You have to make sure you label correctly because they're all different. Okay, so you need to make sure you get comfortable with this 45, 45, 90 so that you don't confuse yourself with the 30, 60, 90. Okay? So I'm going to play this, but you really need to go back to here to get comfortable because the numbers are easier than going into here. All right, because this will build off of it. All right, so here we go. Your legs are 1 and rad 3 and your hypotenuse is 2. So if your question is, well, how do I know which leg to label which one? Perfect question. Okay, so here we go. So these are the 4 triangles you're going to draw. And notice it's not like we already did the 45 where I drew, I think, like 8 different ways. I'm just doing it 4 ways because at this point you should now understand that you pay attention to how it's oriented. Okay. Okay, so here's a trick to label correctly, and we're going to use division to assist me in labeling correctly. Okay, so if it's kind of weird, you'll hear me repeat it so many times you'll get comfortable with it. Okay, so you're going to use division. So if you notice, what are your angles on a 30, 60, 90? 30, 60, 90 degrees. 30, 60, 90 degrees. 30, 60, 90 degrees. 30, 60, 90 degrees. Okay, they're kind of multiples of 3, right? Or of 30. Okay, so look. To label the 30-60 side of the triangle, right, because there's a 30-60 side, it's right here. It's your hypotenuse. Your hypotenuse is always the 30-60 length, 30-60, right? Because look, here's the hypotenuse. I'm sorry, here's the 90 degrees. That's the hypotenuse. There's 30-60 degrees. Here's the 90-degree angle, right? You're right. There's my hypotenuse. That's the 30-60 side. Here's my hypotenuse. I'm sorry, here's my 90 degrees. This is the hypotenuse. There's your 30, 60 angles, right? So that's your side. So your hypotenuse is always the side where the angle's 30, 60, right? Okay, so here's the trick. If you were to divide 30 into 60, like the number 30 into 60, you would get 2, right? Because what is... I'm trying to get you, right? If you ever want to know how to do something, ask yourself, well, what do you know? And 60 divided by 30 is 2. Okay, so 30 goes into 62 times, right? 60 goes into 32 times. So when you look at these triangles, the 30, 60, 90 reference triangle, your 30, 60 side of the triangle, which is always your hypotenuse, is always the length 2. So we're going to use division as a trick to help us label correctly. So if I grab my pen, right, my 30 goes into 62 times. So 30 goes into 62 times. And so my hypotenuse is always the 2 length. That's the side length, is always 2. So here's 90 degrees. This side is hypotenuse. That's my 2. Okay, so let's go to another side. Let's go to the 30-90 side. Here's the 90 degrees. Here's the 30 degrees. So this leg, which is 30, 90, right? Here's 30, 90. And notice, I'm only going to label one of these triangles, and then after we're going to do the other three together, like all together, okay? So with each step, I'm going to come back to this one. Okay, how many times is 30 divided into 90? All right, so 30 divides into 90 3 times, right? 30 divides into 90 3 times. Okay, but here's the thing. Your legs are length 1, and your leg is also length rad 3. So when 30 goes into 90, you just got to know, it's rad 3. Remember, this is a trick to help you label. Doesn't mean it's like exactly like it, right? We're kind of using that trick. So the 30-90 side, right? 30 goes into 90 3 times, but you just got to know that it's actually rad 3. Okay, so the 30-90 side is the leg rad 3. Okay, so now you're left with 60-90. Well, if the legs are 1 and rad 3, by process of elimination, that would just be the one side. But again, look, this is 60 degrees and 90 degrees. Okay, so go back to division. Remember, we're using division to help us with this trick on how to label correctly. 60 divides into 90 like one time, right? Yeah, you're going to have like 30 extra, and then it's going to be like 0.5, but who cares about that? We're not trying to do exact division. It's just, hey, let's help us try and figure out what it gets labeled, okay? So 60 goes into 90 like one time, right? Kind of. Okay, so the 60-90 leg is 1. And so that's how you label the 30-60-90 triangle. Okay, 30 goes into 62 times, 30 goes into 90 3 times, but you have to know it's the rad 3, and 60 goes into 90 1 time. This is just a trick, okay? It's not like it has to be. It's just a trick. Okay, so let's go to the second triangle. 30 goes into 60 2 times, 60 goes into 90 1 time, 30 goes into 90 3 times, but you got to know that's the rad 3. The 3 is the radical. And remember, all of this is supported by the Pythagorean Theorem, right? 1 squared is 1, rad 3 squared is 3, 1 plus 3 is 4. What's 2 squared? 4, right? So it supports it. Again, 30 goes into 90, that's the 2 side, right? And that's obviously the hypotenuse. 60 goes into 90 once, 30 goes into 90 3 times, but you got to know that has the rad 3. Not too bad. 30 goes into 60 2 times, 30 goes into 90 3 times, but that has the rad 3, 60 goes into 90 once. So it doesn't matter how the triangle is positioned, rotated, spun, doesn't matter, spun. You should know how to label it. Fair enough. All right, let's get to work. All right, 2 ways, right? We're going to solve it the color way, and then we'll solve it the shortcut way. All right, so let's do the colors. So remember, you first draw your reference triangle in the same position. So here's my 30, here's my 60, right? 30, 30, 60, 60, right? That's my base, this is my vertex, here's my 90, right? Okay, 30 goes into 60 2 times, 30 goes into 90 3 times, but that's my rad. 60 goes into 90 once. Okay, so now and now you want to get comfortable. I need to pull this back. You want to get comfortable with your, sorry, I wish I never have this ready. All right. And remember, if you have the way you want to solve it, if you like the shortcut method, then you're not copying this, right? You're going to wait for the next. Okay, and so now what happens with the 45-45-90 lecture, we went over a lot of radical, right, rules. So we're going to use them here. Okay, so I should have done this correctly, right? Mu, this is the new triangle. This is the reference triangle. Nu over reference, nu over reference, nu over reference, right? Left to right, x over rad 3, 7 over 1, y over 2, right? goodness, you know I've messed up before, so let's not mess this up. Okay, so how do you solve for x? Cover that up. That's your proportion. How do you solve for y? Cover that up, right? Cover that up. That's your proportion. Okay, so let's go ahead and set it to the side. So x over rad 3 is 7 over 1, because this is your scale factor, right? I always put my scale factor in the middle, just so that you kind of have it positioned that way, but you're not obligated to. Okay, so cross product property, CPP, not Cal Poly Pomona. Okay, x times 1 is x. 7 times rad 3 is 7 rad 3. Perfect. Ta-da. Right? Okay, solve for y. 7 over 1, y over 2, 14 equal y. So y is 14. That is it, right? Can you imagine? Oh my God, we were what, 40 minutes in that other video? I shouldn't talk. I'm already at 11. Okay, shortcut. Here we go. 7y x 60 30. All right, so here we go. Let us grab a red marker, red, and let's shortcut it, right? Less is more, supposedly. Okay, 30 goes into 62 times, 60 goes into 9, whoops, going out of focus. Rad 3, 60 goes into 91 times. Okay. All right, find your scale factor. It is right here. Okay, so your scale factor is the ratio or the division of 7 over 1. So my scale factor is 7. Beautiful, right? Okay, so how do you find x? How do you find y? It's scale factor times reference. So if you want it, well, let's find x first. Okay, reference is rad 3, scale factor is 7. So what is 7 times rad 3? 7 rad 3. So there's your x, right? I'll put x here just because I know it's over there. Find y. Scale factor times reference, 7 times 2, 14. Whoa, I was going to write y there. It wouldn't be me if I didn't mess up. Easy, right? Oh my God, right? And so even writing all this is like super extra. You could have like, let's cover it up. Once you do this, you're like 7 over 1, 7, 14, 7 rad 3. So you can see that once you understand your reference triangles, they're like, it takes more time for you to write it out than sometimes to come up with them. And mind you, this is an easy one because we had it to the 1. Each of the examples, I'm going to have it with the 2 and I'm going to have it with the rad 3. And so how does it get difficult? It gets difficult with the radicals. So it tests you on, can you do it by hand or you use a perfect calculator? Okay. All right, that is the end of the first example, which is the first sheet. Okay, so we're going to put that to the side. And here's a second sheet. Okay, so here's the second and third example. Oh, okay, there's only 4. Okay, so here are the 3 examples. All right, so now I started removing some labels, right? You gotta know. Okay, if this is 30 and that's a 90, right? Then obviously you have to know that this is the 60 side, right? You should recognize that that is. Okay, so let's do the long way or the color way. The proper way. All right, how do you label? 30 divides into 62 times, 30 divides into 93 times, but that's the radical. 60 divides into 90 once. Easy. All right, so here we go. I tell you, it takes way more time to do the colors. Get out of the way. All right. But at least this may, as long as I hold the phone right, this gives you time to build yours, right? Like the markers are really gonna dry out, right? But I have to put the tops back on. It's not gonna dry out, Mandy. Like, I don't know. I'm like, I have to put the top back on. I don't want them to dry out. They're not, though. Okay, here we go. Here's your statement of proportionality, right? All right, so here we go. How do you find x? Right there. How do you find y? Right there. Okay? All right, here we go. So to find the x over 1 is equal to 10 over 2. And then, you know, you get 2x, 10, whatever, you should see it's 5, right? Because 2 just divides into 10, because x is over 1, so you're like, might as well just leave it. And what's 10 divided by 2? 5. Voila. Okay, so y over rad 3, 10 over 2, right? Okay, so okay, so this is up to you. All right, if you want to go the 2y, 10 rad 3, and then divide by 2, you would get y as 2 goes into 10 5 times, 5 rad 3. Okay, or do you want to do this? Do you want to take the rad 3 up, and you would get y is equal to 10 rad 3, 2, and then you would reduce and get 5 rad 3. It is up to you what you see here. So if you feel really comfortable, the correct cross product property where you're like, no, I want to multiply both diagonals. Absolutely. Y times 2 is 2y. 10 times rad 3 is 10 rad 3. But then you're obviously going to just divide that 2 out. So this method, remember when we're doing this with similarity, you could just heavy up the right and just bring that rad 3 up. Leave the 2 because you're going to end up dividing it out anyways, right? You kind of almost do roundabout. You do your little triangle, right? And so 2 goes into 10 5 times. Okay. Oh, I was going to say, why do I have y? I thought I saw for x. My bad. It's up here. So x is equal to 5. Y is equal to 5 rad 3. Okay, you're done. All right, so shortcuts. So this is the second one. Yeah. All right, where's my red marker? All right, 30 goes into 60, whoops. 30 goes into 60 2 times, 30 goes into 90 rad 3, 60 goes into 90 once, right? Okay, find your scale factor. It is right, so pretty, right there. It's the one with 2 numbers staring at you, right? So what is a scale factor? Well, what's 10 divided by 2? 5. Your scale factor is 5. So this triangle is 5 times as large as your 1, 2, rad 3. So what's 1 times 5, right? What's reference times scale factor? That's the value of x. So x is 5. What about y? Scale factor times reference gives you your unknown. If you're getting this and you're starting to cue in on this like step by step, you're just like, okay, Miss Kenny, you're writing a lot. Can I do less? Like seriously, that's how it goes. And you're gonna be like that next year in the spring with IM3. You're gonna be that quick. Okay. All right. Oh wait, I'm ready to do the third one. Duh, I have to do it the long way. Okay. So let's do the third one. All right, so if this is a 60 side, this is the 30 side. All right, so let's draw our triangle. This is 30, this is 60. Okay, 30 goes into 60 2 times, 60 goes into 90 once, 30 goes into 90 3 times, but it's the rad 3, right? All right, let's do this. And I think it's gonna start pushing down because I'm writing too much. Nope, don't go anywhere. And so now notice our scale factor, this time I put it over the rad 3, right? So I try to make sure to hit every type. That's what we're doing here. All right, here we go. Okay, how do you solve for x? there. How do you solve for y? There, right? Statement of proportionality. Who would have thought it just dilations, similarities, right, with triangles or any other similar shapes. Trig. Amazing, right? Okay, here we go. X over 1, 6 over rad 3. Okay, you have the capability of a calculator, right? So what's 6 down rad 3, right? Okay, so if you don't want to do it by hand, it gives you 2 rad 3. That's it. So x is equal to 2 rad 3. On the shortcut, in the shortcut, I'll solve it without the calculator, okay? Okay, so now solve for y. Y over 2, 6 over rad 3, right? Okay, multiply, right? So I get 12 over rad 3. So grab a calculator. What is 12 over rad 3? And remember, there's no shame in doing this with the use of a calculator for rad 3. So now y is equal to 4 rad 3. And there you go. Okay, but for you mental math people, you're like, nope, take that calculator away from me. I want the brain power. All right, here we go. Oh, red marker, duh. All right. 30 goes into 60 twice, 60 goes into 90 once, 30 goes into 90, rad 3 times, right? Because remember, this is your 90-degree angle, right? And remember, 2 is always opposite your 90 degrees. 2 is always the hypotenuse. 1 and rad 3 are your legs. Okay, where is your scale factor? Right there. Okay, we already did that on the calculator, and if you don't remember, I think I said 2 rad 3. 6 rad 3. Oops, you can't even see. It gave you, yeah, 2 rad 3. Okay, so your scale factor is 2 rad 3. Okay, how? Rationalizing the denominator, right? So remember, these numbers are your scale factor. So 6 over rad 3. All right, so rationalize it by hand. Rad 3, rad 3. Okay, so what's rad 3 times rad 3? Radical 9. What's radical 9? The integer 3. 6 times rad 3 is 6 rad 3, but you can reduce. And so there's your 2 rad 3. And so that's why the calculator gives you that. Calculator's so smart, right? Okay, that's your scale factor. So now find x and y. All right, so what's 1 times 2 rad 3? 2 rad 3. What's y? What is 2 times 2 rad 3? Well, integer, integer. This 2 is an integer, this 2 is an integer, this 3 is a radicand. You can only multiply like numbers. So 2 times 2, 4 rad 3. Right, and if you don't believe me, 2 times 2 rad 3. Let's move it to the side. 4 rad 3. How could you even doubt me? I do mess up though, so that's okay if you do. Okay, last one. We're on 23 minutes. All right, here we go. Long way. 30, 60, 60. Okay, 30 goes into 62 times, 60 goes into 90 once, 30 goes into 90 rad 3. All right. Right? This is what adds time to this video. The shortcut is like fast. This one is, this one's adding the minutes. Oh, whoops, 8 rad 2 over 2. Oh my God, don't mess up, man. Let's see, y over rad 3, 8 rad 2 over 2. Okay, I was only gonna write the 8, that's why. Don't mess up. X over 1. Okay, so let's make sure, left, right, left, right, left, right, right? X1, left, right, right? Y rad 3, y rad 3, 8 rad 2 over 2. Beautiful. Okay, how do you solve for x? Right there. How do you solve for y? Right there. All right, so x over 1 is 8 rad 2 over 2. All right, so reduce that. 2 is an integer, 8 is an integer. 2 goes into 8 4 times, so x is 4 rad 2. That's supposed to be a 2. It almost looked like I was trying to write a 3. 4 rad 2. Solve for y. Y over rad 3 is equal to 8 rad 2 over 2. Okay, so multiply. 8 is just 8. Rad 3 times rad 2 is rad 6 because they're both the same type of number. Radicand, radicand, right? They're both inside of a radical. So 3 times 2 is 6. Under 2, right? So I still brought down the 8 and the 2. All I did was multiply the radicals. And now reduce. 2 goes into 8 4 times. So y is equal to 4 rad 6. So how does it get complicated? They start giving you radicals and integers in your side lengths, and that's how they make it. That's how they test you. And what they're testing you is really not on your reference triangles. They're actually testing you on your radical properties. Like, do you know how to simplify? Do you know how to rationalize? Do you know how to multiply? And that's what they're doing. Okay. All right, last bits. Okay, I guess I saved 10 minutes. All right, the fourth example. 30, 60, x, y, 8 rad 2. All right, red marker. Let's label it on top. 30 goes into 62 times, 60 goes into 90 once, 30 goes into 93 times, but that gets your radical, right? The 30, 90 side is 3, but it's always radical 3. Okay, where is your scale factor? Right there. All right, so reduce that. What is 8 rad 2 divided by 2? Well, 8 rad 2 divided by 2 is 4 rad 2. So that is your scale factor. Beautiful. Okay, so find x and y. Well, x is easy because that's 1. Scale factor times reference gives me x. So what's 4 rad 2 times 1? 4 rad 2. So pretty. Okay, what about this? What is y? Scale factor times reference gives me y. What's rad 2 times rad 3? I'm sorry, what's 4 rad 2 times rad 3? Well, radical, right? Radicand, radicand, integer. So y is just 4 rad 6. Voila. Yeah, so pretty. So happy. Love this math. Okay, that's it. You've endured. All right, this is the assignment, but probably by now I'm cutting the video and just going straight to my drive to show you. All right, bye. Wally wants to say bye. Right, okay, adios.